Hello, this is Dr. Tech for cisp440, and we are visiting question number 4 of the final exam in 2018 fall semester. So let's go ahead and take a look at this algorithm. And let me get the non-essential items out of the screen first. All right. So the question number 4, let's go back to number 4 and read the question. So question number 4 says, referring to the A-star algorithm. Okay, let me get rid of the highlighting so it's easier to read now. Referring to the A-star algorithm in listing 1 of line 10 is more optimized compared to other published A-star algorithms, and so on. And basically it wants to ask whether the additional condition, which is this part here, may potentially cause my text version of the A-star algorithm not to find the shortest path, as opposed to algorithms that do not have that additional condition in a conjunction. So you can either prove that it does not prevent the A-star algorithm from finding the shortest path, or you can give me a counter example where it does, where there is a case such that this additional condition in a conjunction causes problem and the algorithm ends up not finding the shortest path. So the important part is to get back to the algorithm itself and focus on a few things. So the first thing we want to do is to focus on this particular condition here, because the negation of the theorem. Okay, so I'm going to write it here. It's easier for me to write it here because the algorithm is right next to it, so it's actually easier to look at the arguments that I'm making here. Okay, so let's go ahead and say this is for question number 4. Choosing the wrong pen color. So this is for question number 4, and the negation of the theorem is to say there exists V in O such that f of V is less than g of x. Okay, my palm is causing the problem here. Is false even though a shorter path exists. That's the negation of the theorem, because the theorem originally said if this condition is false, then there should be no shorter path anymore. So the negation of the theorem is to say even though this condition is false, a shorter path still exists. Okay, so let's see what this is going to lead us to. Okay, so now we can say the negation of there exists V in O such that f of V is less than g of x means exactly the same thing as for all V in O, f of V is greater than or equal to g of x. Okay, so this part is kind of given because that's just the negation of the existential quantifier translating into a universal quantifier but negating the predicate itself. But what does that mean? Well, what that means, so the next thing we need to do is to say, what exactly is f of v? F of v is g of v plus the heuristic of going from v to the destination x. That pretty much is the definition of the f value. So what we are really saying here is now to say that for all v in O such that g of v plus h of vx is greater than or equal to g of x. Okay, And we know all the x values are not overestimating because that's a given in the theorem itself. Okay. Um, so what this means is all of the g of v's are not the they're not reflecting the length of the shortest path to the v's. Okay. So this is now implying, because we know a shorter path still exists, but without even adding that part, just knowing this part here means that so when we combine this and that the shortest path is not found yet, means that for all v in O, g of v is actually greater than it's greater than or equal to the length of the shortest path to vertex v itself. Okay, so now the the um, the interesting part about this, so the next line we need to focus on is how we update g of n. So the only update of the g value is over here on line 18. So line 18 is significant because we know that the g values cannot be, let's see, how should I put it? All the updates of the g values cannot be less than the minimum of all the current g values. Okay, there we go. And because of that, we know that we cannot have the g values cannot be any smaller. In other words, we cannot find a shorter path anymore. Okay, so we say that this means the shortest path has a length of at least, okay, I think my logic is not making sense to myself, so let me think about this a little bit. Okay, we know all the g values of all the vertices in O are greater than or equal to the length greater than or equal to the actual length of the shortest path to those vertices. So in order for anything to be updated to have a lower g value, we need to look at line 18. So line 18 says, the the g value of a new vertex, the new g value of a vertex cannot be less than the current g value of a vertex in O already. And as a result, okay, let me pause the recording first because I know what I'm thinking, but I cannot put it into words just yet. So let me pause the recording.